Okay, good morning students. Today we have lecture number 9. Lecture number 9 on fluids. Lecture number 9 on fluids for first year. Okay. So in the previous lecture we have studied about the viscosity, that is, so we have studied about the Stokes law, and then we have derived the expression for terminal velocity, all that things we have studied, and also we have studied about the Poiseuille's equation. Okay. So now the next concept in this chapter, that is fluid mechanics. So next concept, surface tension. Surface tension. So now this is next concept we have to study surface tension. So first we shall study about the intermolecular forces. The force of attraction or repulsion. The force of attraction or repulsion acting between the molecules. The force of attraction or repulsion acting between the molecules are known as intermolecular forces. The force of attraction or repulsion acting between the molecules are known as intermolecular forces. The nature of intermolecular forces is electromagnetic. So these forces are electromagnetic forces in nature. The force of attraction or repulsion between the molecules of a substance, are known as intermolecular forces, and the nature of these intermolecular forces is electromagnetic in nature. So the intermolecular forces of attraction can be classified into two categories. The intermolecular forces of attraction. The intermolecular forces of attraction can be classified into two categories. One is cohesive force. Another one is adhesive force. One is cohesive force, another one is adhesive force. The intermolecular forces of attraction can be classified into two groups or two categories. One is cohesive force, another one is adhesive force. So first let us study about the cohesive force. The force of attraction. The force of attraction between the molecules of same substance. The force of attraction between the molecules of same substance or same kind. The force of attraction between the molecules of same substance is called as cohesive force. Molecules of same substance. The force of attraction between the molecules of same substance is called as cohesive force. Understood? So now a chapis is there. So inside the chapis there will be a large number of chalk molecule, and there will be a force of attraction between chalk molecule and another chalk molecule. One chalk molecule and another chalk molecule, that is called cohesive force. The force of attraction between the molecules of the same substance or same kind, that both the molecules must be of same substance or same kind, then that force of attraction is called as cohesive force. Okay. So because the cohesive force in the case of solids is highest, the cohesive force is strongest in the case of solid molecules, hence solids have a definite shape and volume, definite size or definite shape and volume. The cohesive force is strongest in the case of solids, hence solids will have a definite shape and volume, whereas the cohesive force is less compared to solid in the case of liquids. The cohesive force is less in the case of liquid molecules compared to solids. Hence, liquids does not have a particular shape, but they have a fixed volume. Liquids does not have a particular shape of their own, but they have a fixed volume. And the cohesive force is lowest. Cohesive force is lowest in the case of gaseous molecules. In between the gaseous molecules Hence, the gaseous molecule or the gas does not have a fixed shape or does not have a fixed volume. Understood? The cohesive force is highest in the case of solids and medium in the case of, less in the case of liquid, and very least in the case of gases. Hence, they will not have a particular, that gases does not have a particular shape or volume. Understood? Okay. So, some example for cohesive force, that is the force of attraction. The force of attraction between the water molecules. Because of force of attraction between the water molecules, it will be, that is cohesive force. Because of cohesive force between the water, it will be very difficult to separate two plates which are sticking together with water. That is, if there are two plates are there, two glass plates are there, they are sticked together with water. They are sticked together with water. Then to separate these two glass plates, there is no gum. Gum is not used, only water is used in between the two glass plates, and there is a water is used. And then the glass plates will stick together. To separate these two glass plates, it takes larger force because of force of cohesive force. That is, because of the cohesive force between the water molecules. Because of the cohesive force between the water molecules. Understood? Okay. The drops of liquid coalesce into one. When two or more drops of liquid coalesce into one, when they are brought in a mutual contact. So, if there are a number of drops of liquid are there, if they are brought in a mutual contact, they will coalesce into one drop because of force of cohesion. Because of the force of cohesion, so any number of drops or two or more drops, when brought in a mutual contact, they coalesce into one bigger drop. So, this is also due to the force of cohesion. It is difficult to break. So, these are our example I am just telling. It is difficult to break a mercury droplet, a mercury drop into smaller drops. It is difficult to break a mercury drop into smaller drops because of strong cohesive force between the mercury molecules. Because of strong cohesive force between the mercury molecules. Understood? So, what is cohesive force? The force of attraction between the molecules of same substance or same kind is called as cohesive force, and due to the cohesive force, it will be very difficult to break a mercury molecule, to break a mercury drop into smaller pieces. It will be difficult because of force of cohesion, strong force of cohesion. And when two or more liquid drops are brought together, they coalesce into one bigger drop. So, this is also due to the force of cohesion. Understood? Okay. So, next comes adhesive force. So, these all are intermolecular forces. These all are nothing but intermolecular forces of attraction. Okay. Adhesive force. The force of attraction between the molecules of different substance. The force of attraction between the molecules of different substance. The force of attraction between the molecules of different substance or different kind. The force of attraction between the molecules of different substances or different kind is called as adhesive force. The force of attraction between the molecules of different substance. So, here the two molecules will be different. So, two different molecules, between the two different molecules there will be a force of attraction, and that force of attraction we call as adhesive force. The force of attraction between the molecules of different substances is called as adhesive force. Understood? Okay. So, now example for this one, adhesive force. So, we are able to write on the board with chalk. We are able to write on the board with chalk because of adhesive force. Because the chalk molecules are different and the molecules on the board are different. The molecules of the chalk are different and molecules of the board are different. So, when we write the chalk on the board, the chalk molecule will stick with the board. because of force of adhesion, because of force of adhesion. Or we are able to write on the paper with pen, we are able to write on the paper with ink pen, so that is also because of force of adhesion. So force of adhesion enables us to write on the paper with pen. And Fevicol and gum are used to stick to different substances. Fevicol and gums are used to stick to different substances having a force of adhesion. They are also having force of adhesion. So these are some examples for adhesive force. Hope you understood cohesive force and adhesive force. Cohesive force is force of attraction between the molecules of same substance, and it is force of attraction between the molecules of different substances. Okay. So now, depending upon this cohesive force and adhesive force only, we can study some scientific phenomena. We can study or we can explain some scientific phenomena like water wets glass. Water wets glass. Why water wets glass? Okay, one question. Another question. Mercury does not wets glass. Does not wets glass. Water wets glass. Mercury does not wets glass. So give the scientific explanation for these two. So these two can be explained only by using a cohesive force or adhesive force. Let us see. So this is the glass plate. This is a glass. And now this is water. Okay. This is water. So water. Okay. This is water. Okay. So water wets the glass plate. The water wets the glass plate. So this is because the force of adhesion between molecules of water and the glass is stronger. The force of adhesion between water and glass, between the molecules of water and glass is stronger than the force of cohesion between water molecules. So this is water means it will be consisting of water molecules. Okay. So between the water molecules there will be a force of cohesion, and this is glass, and between the glass there will be also force of cohesion. Okay. So now glass and water molecule, between the glass and water molecule there will be a adhesion force, and adhesion force is stronger than the cohesion force between the water molecules. The force of attraction between the glass molecule and water molecule will be more than the force of attraction between the two water molecules. Hence, water wets the glass surface. Understood? That is, water wets the glass surface. This is because the force of attraction between the water molecules and glass, the force of attraction, that is the adhesive force between the water and glass is stronger than the force of cohesion between the water molecules. Force of cohesion between the water molecules. Hope you understood the concept. Okay. So now it is observed that mercury does not wet the glass surface. This is glass surface and this is mercury, and mercury does not wet the glass surface. Okay. So here the mercury means here there will be mercury molecules and there will be a force of adhesion between the mercury molecules, and this is glass. Between the glass and mercury molecule there will be a cohesive adhesive force, and between the mercury molecules there will be a cohesive force. Okay. The force of attraction, that is the cohesive force between the mercury molecules, is stronger than the adhesive force between the glass molecules and mercury. The adhesive force between glass and mercury, is less than the cohesive force between the mercury molecules. Hence, the mercury does not wet the glass surface. Understood? So, The mercury does not wet the glass surface because these mercury molecules attract together with a stronger force compared to attraction of the glass to the mercury molecule. Attraction of glass molecule to the mercury molecule will be weaker compared to the attraction of the mercury molecule to mercury. Understood? So, attraction force between mercury molecules to the mercury will be stronger compared to the attraction between the glass and mercury. Whereas in the case of water and glass, the force of attraction between glass molecule and mercury molecule will be more compared to the force of attraction between two water molecules. Hence, the water will wet the glass surface. Understood? So, this can be explained like this. Understood? So, now, next, these cohesive force and adhesive force are inversely proportional to the 8th power of the distance between the molecules. Remember that? The cohesive force or adhesive force are inversely proportional to the 8th power of the distance between the molecules. Okay. So, now next concept, it is surface tension. Okay. I will tell the definition of surface tension. Surface tension, the property of a liquid due to which its free surface, tries to have minimum surface area and behaves like a stretched elastic membrane. The property of a liquid due to which its free surface tries to have minimum surface area and behaves like a stretched elastic membrane is called as surface tension. So, surface tension is the property of a liquid by virtue of which a liquid surface tries to occupy minimum surface area. Surface tension is the property of the liquid by virtue of which a liquid surface tries to occupy minimum surface area and behaves like a stretched elastic membrane. Understood? Okay, this is definition. So, the surface of a liquid always in a state of stretched elastic membrane. The surface of a liquid acts like a stretched elastic membrane and it is always in a state of tension. This is due to the molecules of the liquid tries to come very close to each other. The surface of a liquid acts like a stretched elastic membrane and it always will be in a state of tension. This is due to the molecules of the liquid tries to come very closer to each other due to the force of attraction, and this force of attraction is surface tension, and the surface tension is measured by the force acting per unit length. The surface tension is measured by the force acting per unit length on either side of an imaginary line drawn on a liquid surface. Let us consider a liquid surface. On this liquid surface, draw an imaginary line. So, draw an imaginary line. The force acting per unit length, of an imaginary line on either side of an imaginary line drawn on the liquid surface is called surface tension. See here, I am telling definition and how to measure and what is the cause of surface tension, all the things at the same time. What is definition? The surface tension is the property of the liquid due to which its free surface tries to have minimum surface area and behaves like a stretched elastic membrane. Okay. So, now the free surface of a liquid acts like a stretched elastic membrane and it is always in a state of tension. This is because the molecules of the liquid come tries to have a tendency to come very closer to each other because of force of attraction between the molecules, because of force of attraction between the molecules, and this force we called as surface tension. Understood? And thus surface tension is a cohesive force. Surface tension is a cohesive force, and it is measured by the surface tension is measured by the force acting per unit length. Force acting per unit length on an imaginary line drawn on a liquid surface. The force acting per unit length on an imaginary line drawn on a liquid surface is called surface tension. That is, if F is the force acting on either side of an imaginary line of length L. If F is the force acting on either side of an imaginary line of length L, then surface tension is given by T is equal to F divided by L. Surface tension is denoted by, I will denote it as T. So T is equal to F divided by L. Understood? See here, once again I will tell. Surface tension is measured by the force acting per unit length. Force acting per unit length of an imaginary line drawn on the liquid surface. So this force will be perpendicular to the imaginary line and tangential to the surface. The force will be perpendicular to the imaginary line and tangential to the surface. Understood? So if F is the force acting on either side of the imaginary line of length L, then surface tension is given by T is equal to F divided by L. The SI unit of surface tension is, what is the SI unit of surface tension is Newton per meter. The SI unit of surface tension is Newton per meter, and CGS unit, the CGS unit of surface tension is dyne per centimeter. And the dimension of surface tension is, m raised to 1. L cancel, so you will get T raised to minus 2. So m raised to 1, T raised to minus 2. And it is same as, all these things are same as force constant. All these things are same as force constant or spring constant. We will study force constant or spring constant. That force constant will have same unit and dimension as that of surface tension. Understood? And surface tension is a scalar quantity. Remember all these things. Understood? So what is surface tension? So it is, once again I will tell the definition. The property of a liquid by virtue of which the liquid surface tries to occupy minimum surface area and behaves like a stretched elastic membrane. This property of the liquid we call as surface tension, and it is measured by the surface tension is measured by the force acting per unit length of an imaginary line. Force acting per unit length on either side of an imaginary line drawn on the liquid surface. So consider a liquid surface on which an imaginary line is drawn. So there will be a cohesive force. So now this force acting per unit length is called as surface tension. Understood? Okay. See here, in a liquid, the molecules of the liquid will have tendency to come very closer to each other because of the force of attraction. And this force of attraction is nothing but cohesive force, and this force per unit length on an imaginary line drawn on the liquid surface we called as surface tension. Understood? So surface tension is a cohesive force. Remember all these things. Understood? Okay. So now some examples of surface tension. Examples of surface tension. The mosquitoes and small insects, tiny insects crawl on the surface of water. The mosquitoes and small insects, tiny insect crawl on the surface of water. This is because of the surface tension of water. The weight of the mosquito or tiny insects is balanced by the surface tension force. The surface tension force present in the liquid surface, that is water surface, will supports the weight of the mosquito or tiny insects and their eggs also. The mosquito eggs will also float on the liquid on the water needle. A greased iron needle, when a gently placed when gently placed on the surface of the liquid so that it does not prick the liquid surface. When a greased iron needle is gently placed on the surface of water so that it does not prick the surface of water, then the greased iron needle will floats on the surface of water. Here, the greased iron needle floats on the surface of water when it is placed very gently without pricking the surface of water. So this is because the surface tension of the water will balances the weight of the iron needle. Even though the density of the iron is greater than the density of the water, then also the iron needle floats on the water. So similarly, a razor blade, third one, when a razor blade gently placed on the surface of the water, it will also floats on the surface of water. This is also because of surface tension. Okay, next, the hairs of the shaving brush, or painting brush. The hairs of shaving brush or painting brush, when immersed in the water, they will spread out. And when they removed out of the water, they will stick together. Here, a shaving brush or a painting brush. If you take a shaving brush or painting brush and immerse it inside the water, when it is immersed inside the water, the hairs of the brush will spread. And when you take the brush away from the water into the air medium, the hairs of the brush will stick together. So this is due to the surface tension. Here, I will draw a simple diagram. So then let us consider these all are the hairs of the brush. Okay. When the hairs of the brush present inside the water, so they will spread. And when they removed away out of the water, a elastic liquid membrane is formed between the hairs, and when it is moved out of the liquid, this elastic water surface will have a tendency to occupy minimum surface area. Hence, this elastic membrane, that is this liquid, that water surface, will attract the hairs of the brush, and as a result they will stick together. So hence, so this can be explained like this. Understood? Okay. Next, another point. A oil drop spreads on cold water, whereas a oil drop may not spread in hot water. A oil drop spreads on cold water, but whereas it may not spread on the hot water. This is because the surface tension of oil drop is less than the cold water. The surface tension of oil drop is less than the cold water, whereas greater than the hot water. The surface tension of oil drop is less than the cold water, whereas greater than the hot water. Understood? The shape of a liquid, that is raindrop. The shape of the raindrop is almost spherical. The raindrop will have spherical shape. This is due to the surface tension. This is also due to the surface tension. That is, the molecules of the water will tries to occupy the minimum surface area. will tries to come very closer to each other, and for a given volume, the sphere has a minimum surface area, hence the liquid drop, a small liquid drop will have a spherically in a shape. Understood? And one more experiment you can do. In the absence of gravitational force, a liquid drop will be perfectly a sphere. A liquid drop will be a best sphere, spherical. It will looks like a correct sphere. Whereas, so the raindrop, the shape of the raindrop is something like this. It is sphere, but little bit not perfectly sphere. So like this. So this is due to the gravitational force. If the gravitational force is neglected, if there is no gravitational force, then the raindrop could have been perfectly spherical in shape. Understood? So this is due to the surface tension. Understood? Okay. So these all are some examples we can explain on the basis of surface tension. So now, the factors on which surface tension depends. The factors on which surface tension depends. Okay. The surface tension, the factors on which surface tension depends. The surface tension depends upon the state of purity. The surface tension depends upon the state of purity. And second one, the surface above the free surface. The medium above the free surface of liquid. The medium above the free surface. The medium above the free surface. The medium above the free surface. Temperature. The surface tension depends upon the state of purity of liquid, and the surface tension depends upon the medium above the free surface. What medium is there above the free surface, whether it is air medium or some other medium. And the surface tension also depends upon the temperature. Understood? So now, let us study the effect of temperature on surface tension. Now we shall study the factors affecting the surface tension. Factors affecting surface tension. Okay. First one, temperature. As temperature increases, the surface tension of liquid decreases. As temperature increases, the surface tension of the liquid decreases, and the surface tension of the liquid is 0 at its boiling point. Okay. So now, as temperature increases, the surface tension of the liquid decreases. On this, there is an example. For example, it is the hot soup tastes better than the cold soup. Hot soup tastes better than the cold soup because the surface tension of the hot soup will be less. Hence, the hot soup spreads well inside the mouth, spread evenly inside the mouth, whereas cold soup will have larger surface tension and it does not spreads well inside the mouth. Understood? And next point, another one. So that is the machinery parts are jammed in winter. So due to the low surface tension of oil or grease used in the machinery parts. Understood? And next, second one, impurities. When highly soluble impurities like sodium chloride, when added to the water, it will increase the surface tension of water. When sodium chloride is introduced or mixed with the water, the surface tension of the water increases. Whereas sparingly soluble, that is less soluble substances like phenol is dissolved in water, dissolved in a liquid, then surface tension will decreases. The surface tension is decreases. So sodium chloride when added to the water, the surface tension will increases, and when phenol is added, the surface tension will decreases. Now let us study the Let us study the applications of surface tension. Applications of surface tension. Okay. So the first one, the dirt spots on the cloth, that is the grease or the grease spots, the grease or oil spots, the oil dirts or grease dirts on the shirts or on the cloths cannot be removed easily with water, pure water. But when the detergent is mixed in pure water, the surface tension of the water will decreases, and then water will penetrates into the interior of the cloth, and then it will cleanse the dirt spots. Understood? Second point, the antiseptics will have very low surface tension. The antiseptic tubes will have very low surface tension, so that it penetrates when it is applied on the skin, it penetrates into the skin and it spreads properly. That's why the antiseptics will be made having a less surface tension. And the surface tension of oils used in the machines are kept low. The surface tension of the oils used in the machines are kept low, so that they spread properly. Oil spreads over the surface of water. So because oil has less surface tension than that of cold water. Oil has less surface tension than that of cold water. So these are some applications of surface tension. You can understand. Okay. Now let us study the molecular theory of surface tension. First understand few concepts. The maximum distance up to which the force of attraction between two molecules is appreciable. The maximum distance up to which the force of attraction between two molecules is appreciable is called molecular range. The maximum distance up to which the force of attraction between the two molecules is appreciable. The maximum distance up to which the force of attraction between the two molecules is appreciable, that distance we called as molecular range, and it is of the order of 10 to the power minus 9 meter in the case of solids and liquids. A sphere with the molecule at the center, and the radius equal to the molecular range. A sphere with the molecule at the center and the radius equal to the molecular range is called as sphere of influence. Here, understand properly these two words. It will be used while explaining that one. What is molecular range? The maximum distance up to which the force of attraction between the two molecules is appreciable. That distance we call as molecular range. A sphere with the molecule at the center, and the radius equal to the molecular range is called as sphere of influence. So now, to understand the molecular theory of surface tension, let us consider four molecules A, B, C and D in the liquid, inside the liquid. The molecule A, that is the molecule A, which is here. All the molecules which are within the sphere of influence of molecule A will tries to attract the molecule A. That is, all the molecules which are present within the sphere of influence of molecule A will tries to attract the molecule A. Thence, the net force acting on the molecule A becomes 0. The net force acting on the molecule A becomes 0. For example, this is molecule A. So there is another molecule, here also. This molecule tries to attract this molecule this side. Okay, here also it will attract, here also it will attract, here also it will. Like this, all the molecules which are present within the sphere of influence tries to attract the molecule A. As a result, the net force on the molecule A becomes 0, and hence, so it is free to move inside the liquid. Whereas the molecule C, in the case of molecule C, the molecules attracting the molecule C in the downward direction are more, whereas the molecules in the upward direction is less. That is, within the sphere of influence, the molecules within the sphere of influence in the upward direction is less. Hence, a net force acts on the molecule C in the downward direction. A net force acts on the molecule C in the downward direction. And now see the molecule D. So now for a molecule D, there are no molecules in the sphere of influence in the upper half. There are no molecules in the sphere of influence in the upper half. Only the molecules are present within the sphere of influence inside in the downward direction. Hence, the molecule D will experience as a net downward force. It will experience as a net downward force. Or all the molecules which are present within the surface PQRS. The molecules, all the molecules of the liquid which are present within the surface PQRS will experience a net downward force, and hence they will have a maximum potential energy. They will have a maximum potential energy. See here, the net downward force is maximum. The net downward force is maximum. So hence maximum for the molecules on the surface of the liquid, and hence they will have a maximum potential energy. For the system to be in equilibrium, the potential energy must be minimum. For the system to be in equilibrium, the potential energy must be minimum. Hence, the surface will have minimum number of molecules. The surface will have minimum number of molecules. Hence, the surface will tries to occupy minimum surface area. The surface of the liquid tries to occupy minimum surface area and behaves like a stretched elastic membrane. Understood? See here, there will be a net downward force for all the molecules which are present within the surface PQRS. Hence, they will have a more potential energy compared to the molecules which are well within the body of the liquid. So, compared to the molecule A, the molecules which are present within the PQRS will have more potential energy compared to molecule A, compared to all these molecules which are well within the body of the liquid. So, for the potential energy is maximum. So, for a system to be in equilibrium, the potential energy must be minimum. So, for that, the surface will have minimum number of molecules. The surface will have minimum number of molecules. Hence, it will try to have minimum surface area. The liquid surface will try to occupy minimum surface area and behaves like a stretched membrane. So, this is the molecular theory of surface tension. Hope you understood. This is the molecular theory of surface tension. Understood? Okay. This much is enough for this class. In the next class, we will study more about the surface tension. Okay.